here's what our pendulum looks like. Here's the rod of length L that was given in the problem and has a mass that I call little m. And on the end of it is this disc, which has a mass that I call big M and a radius r. And the first thing they ask you in part A is to find the moment of inertia. Well, the total moment of inertia is going to be the moment of inertia of the rod plus the moment of inertia of the disc. Now, we have a formula for the moment of inertia of a rod rotated around its end. It's 1/3 the mass, which I'll call little m, times the length of the rod squared. Now, the disc is not rotating around its center, right? It's rotating around this point up here. So it is not 1/2 mr squared disc. It's actually a bunny on a string. And so the moment of inertia of the disc is just going to be the mass of the disc times this length squared from the pivot to the center of mass, that length. And that length is r plus L. So that's going to be the way we're going to calculate the moment of inertia. Next, they want us to find the center of mass. Well, to find the center of mass of this combined object, what we need to do is find the centers of mass of the two things and then work with that. So if I look at the rod, I see that the center of mass of the rod is located right in the middle, right here. The distance from the pivot to this center of mass is L/2. As for the disc, the center of mass of the disc is here, and its distance from the pivot is, again, r plus L. So when I go to calculate this, I'm going to use my formula for finding the center of mass. Remember, the position of the center of mass is m1 x1 plus m2 x2 all over m1 plus m2. It's just a weighted average. So we got the center of mass is going to be equal to the first one, which is little m, times its distance, L/2, plus the second one, which I call big M, times its distance, r plus L, divided by the total of mass, m plus m. And I'm going to call that letter D, because that's how we're going to use it in the next part. So in the last part, they want you to find the period of this pendulum, which is easy. We have a formula for that. It's 2 pi square root of I over mg/d. I, we calculated in part A. D, we calculated in part B. And for the mass of this pendulum, of course, we have to use the total mass, big M plus little m. And that's how you do it.